Solving equations using factoring. We have used factoring to solve quadratic equations, but it is a technique that we can use with many types of polynomial equations, which are equations that contain a string of terms including numerical coefficients and variables. When we are faced with an equation containing polynomials of degree higher than 2, we can often solve them by factoring. Polynomial equations. A polynomial of degree n is an expression of the following type. We have the coefficients a subscript n times the variable x to the n power plus a subscript n minus 1 x to the n minus 1 all the way to a 2 subscript 2 x squared plus a subscript 1 x plus a subscript 0, where n is a positive integer and a subscript n to a subscript 0 are real numbers and a subscript n is not equal to 0. Setting the polynomial equal to 0 gives a polynomial equation. The total number of solutions, real and complex, to a polynomial equation is equal to the highest exponent n. So example 4, we're solving a polynomial by factoring. The polynomial by factoring is 5x to the fourth, which is equal to 80x squared. So if you look at the highest degree of this polynomial equation, you can see that it's 4. Which means we should end up with 4 solutions. The first thing we need to do is set the equation equal to 0 and then factor out what is common to both terms, which is the greatest common factor. Well, we can factor out 5x squared. If we factor out 5x squared, what's left is x squared minus 16 equals 0. Step number 2, notice that we have the difference of squares and the x squared minus 16, which we will continue to factor and obtain 2 solutions. And the first term, 5x squared, generates technically 2 solutions as the exponent is 2, but they are the same solution. So in this case here, we have 5x squared equals 0. Divide both sides by 5, and then take the square root of both sides. So let's go ahead and do that. We have x squared, which is equal to 0 if you divide both sides by 5. And then when we take the square root of both sides, we take the square root of x squared and the square root of 0, we get x is equal to 0. On this side, we have x squared minus 16 equals 0. Now we can either factor and set them both equal to 0, or we can use the square root property, whichever way you want to go. X minus 4 times x plus 4 equals 0, so we have x minus 4 equals 0, or x plus 4 is equal to 0. Getting the 2 solutions, x equals 4 or x is equal to negative 4. So the solutions are 0, which is a double solution, 4 and negative 4. Now let's take a look at this graph here. We can see the solutions on the graph in figure 1. The x-coordinates of the points are the graph where the graph crosses the x-axis are the solutions, which are the x-intercepts. Notice on the graph that at 0, the graph touches the x-axis and then bounces back. It does not cross the x-axis. This is typical of double solutions. So here, starting from the left, we pass through the first x-intercept, which is negative 4, 0, and then we come back up, and then it bounces. That's because it's a double solution, because we have 2 solutions that are at 0. So that tells us to bounce, and then it comes back going through our other x-intercept for 0.